In this video, we are going to talk about using trigonometric ratios, so trig, as you've probably heard it called, to solve problems in right triangles. So what a trig ratio is it's just a function of a given angle, so you need to have an angle, and it's equal to the ratio of two specific sides of a right triangle. So in this diagram here, you're going to see an angle, and in this case, we're labeling it theta. Theta is just a Greek letter. It's like a variable, so it's like an x here. So you'll see this, and it's called theta. We could also be calling it angle C, since that's the vertex of this triangle. And so you'll see an angle, and then you'll see the sides labeled the opposite side, the adjacent side, and the hypotenuse. Now, the hypotenuse is always, always, always across from that 90-degree angle. That never changes. The opposite angle, the opposite side is always going to be across from the angle that you're working with, okay? So when we're working with this angle, this is going to be the opposite side. If we were looking at angle B, then the opposite side would change, okay? So it's going to be dependent on the angle. So opposite side is across from the given angle. Adjacent side is next to. Okay, so opposite is across, and adjacent is next to, and then remember the hypotenuse is always, always, always the one after the 90-degree angle. So the trig ratios, there are three of them. So we've got three different ones, okay? One is the sine function, so the full version is S-I-N-E. So we would do sine and then the input angle, so theta, so sine of theta. That's going to be the ratio or the division of the opposite side over the hypotenuse. Okay, so always opposite side of the angle divided by the hypotenuse for the sine function. This next one, the shorthand is cos. This is the cosine function. Okay, so we will do cosine of an angle is going to equal the adjacent side, so the one next to the angle, over the hypotenuse. And then tan, or tangent, okay, so this one is the tangent function, is the opposite side over the adjacent side. And then again, remember that these are based on where this angle is. So sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. So you might feel like that's a little bit hard to remember. So there's this little acronym that we use to remember this, and we say SO, CA, TOA. And I'm going to write this on the top of every screen. I would write it on the top of your paper every time you do trig. SO, CA, TOA. So the S stands for sine. And then it gives you the one that goes on top, so opposite side, and then on bottom, hypotenuse. So the sine function is equal to the opposite over the hypotenuse. The cosine function, the C, equals the adjacent side on top of the hypotenuse, so adjacent over hypotenuse. Tangent, opposite over adjacent, so opposite on top, adjacent on bottom. So let's take a look at just writing these ratios out. So if we take a look here, so first off, we want to label the opposite, adjacent, and hypotenuse. Okay, so remember this deals with where the angle is. So we're looking at angle A in this case. Okay, so I like to identify angle A by circling it. Then we need to label the opposite, adjacent, and hypotenuse. So the hypotenuse is always across from the 90-degree angle, so the 29 is the hypotenuse. Across from the angle is the opposite. Next to the angle is the adjacent. Okay, so I'm just using H, O, and A. So now when we go to write out these functions, okay, so when I want to do the sine of A, remember that the sine of A is the opposite side over the hypotenuse. Okay, and remember we can get that from SOHCAHTOA. So I'm looking at sine opposite over hypotenuse. So the sine of A is equal to 20 over 29. cosine. So when we look at the CAH, so cosine is going to be the adjacent side over the hypotenuse. So the cosine of A is going to equal adjacent, which is 21, hypotenuse, which is 29. Then the tangent function is going to be the O over the A, so the opposite side over the adjacent side. So we have tangent of angle A equals opposite 20 over adjacent 21. Okay, example 2. So again, label the sides. So example 2 wants us to be labeling opposite and adjacent for angle B, because now all of these are going to be using angle B. So find angle B in your photo or in your diagram, and then label the sides accordingly. So always across from the 90 is the hypotenuse. Across from the angle is the opposite. Next to the angle is the adjacent. So remember, the sine function is going to be the O over the H. Okay, so the sine function is going to be the opposite side, 12, over the hypotenuse, 13. Cosine is going to be the adjacent side over the hypotenuse. Okay, so I didn't write it up here. Okay, so adjacent side is the 5, and the hypotenuse is the 13. Okay, and again, you can see that from SOHCAHTOA. So we're looking at the CAH. Next is the tangent function. So the tangent function is the opposite of B, which is the 12, over the adjacent to B, which is the 5. And then we can just leave these as fractions. If you could reduce them, if there was any common factors, you could do that as well. If it asks for a decimal, you could just divide these to actually come up with the decimal version. But generally, when we're writing the ratio, we'll just leave it as the fraction. All right, so then let's actually use that to solve triangles. So what we want to do first is label the sides here. So again, look for the angle. Now, we never in geometry use the 90-degree angle, so you need to use a different angle. So we'll use 70, and then we'll label the sides. So across from the 90 is the hypotenuse. Across from the angle is the opposite. So the variable in this case is the opposite side. And next to the angle, the 63, is the adjacent. So now you have to decide which of these functions you want to use. Okay, so look at the side, the filled in. So this H doesn't have anything with it. There's no variable or number, so we're not going to use that. So we want to be using the opposite side because that's the X, and we want to be using the adjacent side because that's an actual number. So looking at the acronym up here, we want to look for the O and the A to be together. So that's going to be the tangent function. So we would do tangent of the angle, okay, because remember it's tangent of theta equals the opposite over the adjacent. So in this case, when we fill in our angle, we'll have 70 degrees. So tangent of 70 equals the opposite X over the adjacent 63. So now we're actually going to solve this because we know that the tangent is always opposite over adjacent. So it's all plugged into your calculator for every specific angle that you could possibly have. Tangent of 1, 2, 3, tangent of 4.7, whatever. It's all in your calculator. So if you're using an iPhone calculator, you can unlock your screen lock and you can turn it sideways, and then you'll see the tangent function down here. You also want to make sure that this button right here says RAD, because that means radian, okay, which means that your calculator is in degree mode currently, and that's because our angles are measured in degrees. We're not going to learn about radians. You'll learn about that in Algebra 2 Trig. Just make sure it says RAD down here. So then you'll hit 70 and then tangent. So you have to type in the 70 first and then hit tangent. I'm also going to show you how to do it on the Delta Math calculator, since you're often in Delta Math. So you would click on the calculator button up here, and then it would bring up your calculator on the bottom of the screen. So then you can push functions, and you'll see the trig functions over here. Okay, so we're doing tangent. Okay, and then I want to go back to numbers. Whoops. Okay, so tangent of 70, and then you'll see over here that it will answer it for you. Okay, and when you're looking at functions, you want to make sure that the degree button is pushed. Okay, so let's take a look at this. Calculator. Let me clear this out. Okay, so when you're in the calculator, you'll hit functions, tangent, make sure degree is highlighted, and then back and type in the angle. Then you can hit enter if you want. It's also right here. Okay, so 2.7474. So this decimal right here is 2.7474, and that equals x over 63. So now we need to solve this for x. So I'm going to look at this as a proportion. So I'm going to put a 1 under here so that I can think of cross multiplying. So we're going to do 63 times that decimal. So I'm just going to leave this in my calculator, and maybe it won't do that on Delta Math. Oh, you can hit answer if you want to, and it'll plug in the previous answer, and then type times 63. And again, it'll tell you the answer right there, or you can hit enter and get 173.1 would be to the nearest tenth. Okay, so x, so that's, sorry, right here. Okay, so 63 times this was 173.1, and then x times 1 is just x. So your final answer would be 173.1. Next example, so label the sides of the triangle for the given angle, then find the value of x. So again, look for the given angle. We don't use the 90, so we're going to use this one. Label the sides. So across from the 90 is always the hypotenuse. Across from the angle is the opposite. Next to the angle is the adjacent. So then you need to decide what function you're going to use. Okay, so again, I look for the variable and a filled in number. Okay, we don't care about the opposite side. The problem didn't ask us to solve for that. So in this one, we have the hypotenuse and the adjacent. So you want to look up here and see which one has the adjacent and the hypotenuse together. So that would be right here. That's the cosine function. Okay, so we're going to set up cosine of theta equals the adjacent side over the hypotenuse. Again, that's CAH. So then we'll fill in our information. So our angle in this case is 23 degrees. So cosine of 23 equals the adjacent side, x, over the hypotenuse, 101. So now it's time to solve. So we're going to type this into our calculator because our calculator knows what the cosine of 23 is. So again, we'll go back into functions, cosine, back, type in 23, hit enter, and we get 0.9205. Okay, so 0.9205, I would do at least 4 decimal places, equals x over 101. Then you can just think of it as a proportion so that you can cross multiply here. So we're going to do 101 times that decimal. So I'll go back to my Delta Math calculator. We're going to take the answer times 101. And we'll get 92.97. So we get 92.97 here equals 1 times x, which is just x. So that side is 92.97. If we were rounding to the nearest tenth, this would round the 9 up, which would actually round it to 93. So if we were rounding to nearest tenth, we'd get 93. Okay, last example. Again, label the sides. So you want to pick the angle. We don't use the 90, so we're going to use this one, 57. Across from the 90 is the hypotenuse. Across from the angle is the opposite. Next to the angle is the adjacent. We don't need the adjacent because there's no variable. We're solving for the hypotenuse and we are given the opposite. So look here at SOHCAHTOA, which one has the opposite and the hypotenuse? Okay, and that's the sine function. So we do sine of the angle equals the opposite side over the hypotenuse. So we'll do sine of 57 in this case is the angle equals the opposite side, 15 over the hypotenuse, x. So we'll go type this into our calculator to get what sine of 57 is. So again, functions, sine, back to, and type in 57. So 0.8386 equals 15 over x. Again, we'll look at this as a proportion. And then we'll cross multiply. So we'll multiply this x up and the 1 up. So in this case, we get x times this. So we're going to get 0.8386x equals 1 times 15, or 15. So we need to solve for x here. So we're going to divide by 0.8386 to both sides. So we're going to do 15 divided by 0.8386. So looking in your calculator, so now you still have this as the answer. So what I'm going to do is type 15 divided by, and then I don't want to type this out. So again, I'm just going to hit answer. Okay, so we're going to do 15 divided by the previous answer. And then hit enter, and you've got 17.89 or 17.9, depending on how you need to round. So it was x equals 17.885. So if we needed to round to the nearest tenth, it would be 17.9. Or if you needed to round to the nearest hundredth, 17.89.